Okay, guys, a dilation is a change in the size of a figure. We know that. It can either make a figure larger or smaller. The scale factor of a dilation is called K. So I'm going to highlight today as well. So on the test, it might say, find K. And you have to associate K as they're asking me to find the scale factor. If K is greater than 1, the dilation is an enlargement. If K lives in between 0 and 1, so a fraction, the dilation is a reduction. Could we ever have a negative dilation?
Yeah, we can. It's just reflected over its center.
Yeah, it will, but if we're not talking about reflections, could we ever have a negative size change? No. But if we added a reflection, so a composition in a minute, then yeah. But when we're thinking about what is the scale factor, a scale factor will always be positive. Okay? All right. Since dilations change the size of the figure, dilation is not isometric. Good. So not isometric. Or isometry. Whatever you want. Isomy. All right. I'm about to write a word. This is the first time we're going to see this word, but we're going to talk about it for the rest of the year. The figures are similar, which means something different in geometry. Not congruent. Oh my god, they call, hold on. Gotta do attendance, but I'm recording. Okie dokie. Keep moving. Enlargements. We can find K by putting the new over the old. What in the world does that mean? We're going to talk about it. So, with my triangles PQR, which one is the pre-image? The small one or the large one? Small one. That's exactly right, because it does not have the little tick mark. It doesn't have prime on there. So the new one from the center point C is 5. And the old one, the pre-image, 2. So there's my scale factor. So 2.5. But I'm going to leave it like that. Okay? So it got larger because it's greater than 1. Okay? So if it was nothing, we multiplied it for 5. Nothing, 2. Alright, let's try the reduction. This one is my pre-image. So I'll write that just in case. And now let's do this. The new one, what number am I going to write on top? So what is K? 1/2. Thank you. Okay. So, it's recording. Yeah. I didn't say come here. I said I'm recording. And you're making random noises. Yep. There we go. Yep. Okay. Alright, dilations on a coordinate plane. So, if I have an image, and this is it, image P, my new image, we're just going to multiply the x and the y by whatever that k is. What does k represent again? Good! Scale factor, look at us. Alright, so let's figure this out. J, K, L, M. Let's figure out where it lives. So go ahead and fill in your coordinates. And now let's see what happened. So J prime is at 0, 1. K prime is at 3, 0. L prime, M prime.
Maybe not. You skip that phase.
So how in the world could I figure out the scale factor? We don't need distance formula. We could do that, but that's going to take a really long time.
Common sense, mental math.
Okay, so what would the mental math tell me is happening here?
We're just dividing by 2, so it could be 1/2.
Exactly. So the original. Yeah. So look, each x value is multiplied by a half. 0 times a half, 0. 6 times a half, 3. 6 times a half, 3. Negative 2 times a half, negative 1. So remember, the scale factor will just be multiplied by the x and y. So could we do distance formula? Absolutely. We could figure out how long each one of these sides are and compare, but that would take a very long time. So k equals 1/2. That's how we would figure it out. Yeah, it's all that easy, yeah. That's why this unit's so short. K is not a point in this case. It's a point and a scale factor. Okay. What's the star? Homework, these are your 2? A and B? Alright, and we're doing the bottom together. This is definitely an SOL type question, so let's talk through it. All you guys are going to make perfect scores on the SOL. Every geometry class I've ever had. Just kidding, I wish. Alright, an 8 by 10 inch photograph. So in geometry, we always draw a picture. 8 inches by 10 inches, just to help us. Even if we read it and it seems so simple, we draw a picture because sometimes we miss something. It's being reduced by a scale factor of 3/4, so we know it's going to get smaller, and they want the new dimensions. So since we know we can multiply by scale factor, what would be the easiest way to find my new dimensions here? Yeah, let's just multiply. 8 times 3/4. So that is just 8 times 3 is 24. 4, 6. So this one is 6 inches. Now some of you guys can do 3/4 of 8 in your head. 2, 4, 6, 8. And if you can do that, perfect. Do it that way. This is just a quick review of multiplying by a fraction for those of you that need it. Now, can I have an even number for 3/4 of 10? No, I can't. So I can do it over here, though. 10 times 3/4, again. 30 divided by 4. Hey, there we go. Good job, guys. There's my answer.
No, it has to be practical. No.
We could. If we did that, we would get 30 over 4, which would be 15 over 2, which is, I'm fine if you do that. You know I love a good fraction. Yeah, agreed. All right, guys, we are going to start the next lesson. That was it.